Okay, let's start by reading the problem description for climbing stairs. You are climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? Example 1, we have an input of 2 and an output of 2 because you can climb it 1 step at a time or 2 steps. Example 2, we have an input of 3 and an output of 3 because you can either climb it 1 step at a time, 1 step plus 2 steps, or 2 steps plus 1 step. For the constraints, n will be greater than or equal to 1 or less than or equal to 45. The climbing stairs challenge is very similar to the Fibonacci number challenge in terms of the mathematical equation you need to solve it, which means you can approach this problem pretty much the same way I approached it in the Fibonacci number video I published yesterday. The naive approach would be to use recursion, and without memoization, this approach has an exponential time complexity and linear space complexity. We're going to go over a more optimal approach utilizing just a simple while loop. This solution has a big O of n time complexity and constant space complexity. Here we have an input of 6. We'll start by setting up a base case that returns n if n is less than 4. Next, we'll initialize a counter with a value of 3 since our first 2 combinations will be taken care of when we initialize our combos array. Then we'll set up our while loop to iterate as long as the counter is less than or equal to our input. The next combination is just the sum of the current values in the combos array. So we add 1 plus 2, which gives us 3. We take the value at the first index in the combos array and assign it to the 0 index in the combos array. Then we assign the next combo to the first index in the combos array. The counter increments to 4. 2 plus 3 gives us 5. We shift the 3 over to the 0 index in the combos array and assign 5 to the first index. The counter increments to 5. 3 plus 5 gives us 8. We shift the 5 over to the 0 index in the combos array and assign 8 to the first index. The counter increments to 6. 5 plus 8 sums up to 13. We shift the 8 over to the 0 index and assign 13 to the first index. The counter increments to 7, which causes our while loop to evaluate to false because 7 is greater than 6. So we exit the while loop and return the first index of the combos array. Let's translate this to code. Okay, we'll start by setting up our base case. We'll check if n is less than 4. If it is, we'll return n. Then we'll initialize a counter with a value of 3. We'll initialize a variable called combos with an array containing 1 and 2, which will be our first 2 combinations. Then we'll set up our while loop that'll iterate while counter is less than or equal to n. First thing inside of our while loop, we'll get the next combo, which is just the sum of the 2 values in our combos array. Then we will assign the value at index 1 in our combos array to the 0 index in the combos array. And then we will assign our next combo to the first index in the combos array. And then we will increment our counter by 1. Then when our while loop exits, we will return the first index of the combos array. And that's our solution. Let's save and run our test cases. And we get the expected output. Let's copy and paste this into Leetcode. Okay, let's paste it in here. Hit submit. And we get an accepted solution.